Hello everyone, welcome to my channel. In this video, we will learn how to manipulate data. A data frame is one of the most used data objects, because it is useful for storing data with different data types, and can be easily presented. Subsetting data is a common task, when we work with a data frame. In a previous video, we learned how to subset an object, by using 5 index vectors. We can use these index vectors, to select elements from a data frame as well. We will use the Painter's data frame, from the Mass library, to illustrate how to subset data. The Painter's data frame contains the subjective assessment, on a 0 to 20 integer scale, of 54 classical painters. The painters were assessed on 4 characteristics: composition, drawing, color, and expression. The row names of the data frame are the names of the artists. For example, to subset painters by selecting observations, with color score greater or equal to 17, we need to create an index vector, by comparing the color variable with 17, and insert this index vector at the first position, within the square brackets. Remember that placing an index vector at the first position, is to select rows from a data frame. This example shows how to select observations, with school variables equaling to A or D. The logical index vector is created, by using the is.element function. Instead of using the is.element function, we can also use % operator. The first argument of the is.element function is the school variable, with a length equaling to 54. The second argument is a character vector, that contains values of A and D. The is.element function is checking, whether each element in the school variable equals A or D. If it is, it returns true, otherwise, it returns false. The result from the is.element function, is a logical vector with the same length as its first argument. Using the is.element function, to compare two vectors, is not equivalent to using the double equal comparison operator. Using the double equal comparison operator, is checking if the first element of the school variable equals A, and the second element of school variable equals D, then checking if the third element of school equals A, and the fourth element equals D, and so on. The recycling rule is applied, when using the comparison operator. A data frame shares the common properties of a matrix and a list. Therefore, we can use the method of selecting elements from a matrix or a list, to select columns from a data frame. For example, the school variable is the 5th variable, and color is the 3rd variable in Painters. The first two commands treat the data frame like a matrix, by placing the index vector at the second position, within the square brackets. The last two commands select variables, by treating the data frame like a list. These 4 statements are equivalent. We can select observations and the variables at the same time. The example selects observations with schools equaling to A, but only keeps the school and color variables. A common task to manipulate data frames, is to create new variables based on existing variables. For example, we often need to create an indicator variable, by comparing a continuous variable, with a threshold value. The indicator variable can be either a numeric vector, with values of 1 or 0, or a logical vector of true or false. In this example, we add a new indicator variable, by comparing the drawing variable with its mean value. This example shows how to create an ordinal variable, based on the composition variable. If the composition is less than 8, the new variable will be assigned with 1. If composition is greater than or equal to 8, but less than 12, R will assign 2. And lastly, if the composition is greater than 12, R will assign 3 to the new variable. If you are not very clear about how this statement creates the ordinal variable, you can examine the bottom table closely. Remember, the result from a comparison is either true or false. During the calculation, true becomes 1, and false becomes 0. There are 3 components in the assignment statement. The first element is 1, the second component is comparing composition with 8, and the last component is comparing composition with 12. For example, in the first row of the table, the composition equals 10. Since 10 is greater than or equal to 8, the second element results in true or 1. Since 10 is not greater than or equal to 12, the comparison results in false or 0. Adding 1, 1, and 0 results in 2. Once we finish creating this ordinal variable, we can use the tapply functions, to check if this variable is correctly created. The result from the first tapply function shows that, the minimum value of composition within each level of the newly created variable is 0, 8, and 12. The result from the second tapply function shows that the maximum value of composition within each level of the new variable is 6, 11, and 18. These statistics tell us that this new variable is correctly created. Now, let's see how to use the ifelse function to create a new variable. The ifelse function returns a vector with the same length as its first argument. The first argument is a logical vector. The result is filled with elements, selected from either the second or the third argument, depending on whether the element in the first argument is true or false. For example, school variable has values of a to h. Suppose we would like to create a new variable named school2. If school equals a, b, or c, we will assign 1 to school2, otherwise, we will assign 2. The first argument of the ifelse function uses is.element function to generate a logical vector. The second argument is 1, and the third argument is 2. If the school variable equals a, b, or c, the is.element function will return true, which will result in 1, from the ifelse function, otherwise, the ifelse function will return 2. We can place an if-else function within another one. In this example, we create school3, containing 3 levels. In the situation when school equals a, b, or c, the if-else function returns 1. The last argument of the if-else function contains another if-else function, which returns 2 or 3, depending on whether the school variable equals d or e. The table function generates a cross-tabulation of school3 and the original school variable. By checking the result from the table function, we can see school3 is correctly created. The cut function is useful to create a categorical variable, based on a continuous variable. Suppose that we'd like to create a 4-level factor, based on the color variable. The dividing points will be based on the first quartile, median, and third quartile of the color variable. We can use the quantile function to obtain these dividing points. The quantile function takes a percentage value and returns the quantile value. In the last command, we use the quantile function to create a numeric vector containing the dividing points. We also specify 0 and 1 to obtain the minimum and maximum values of the color variable, since these 2 points are needed in the cut function. Now, we use the cut function to create a factor based on the vector that is generated from the quantile function. The first argument of the cut function is a numeric vector that needs to be divided. The second argument is to specify the breakpoints. Since we are dividing color into 4 segments, we need to provide 5 points, which include the minimum and maximum values of the color variable. These 5 data points are stored in the Qt vector. By default, the minimum value of the numeric variable is not grouped or categorized into any level. The third argument is to specify values to name each level in the result. In the cut function, we used first, second, third, and fourth as values for each level. For the fourth argument, setting include.lowest to true will include the minimum value in the lowest level. For the fifth argument, setting right to false, the minimum value of the continuous variable, x, will be grouped into the lowest level, but the maximum value will not be grouped into any level. Sorting a data frame is a common task for a programmer. We can use the sort function to sort a vector. By default, the vector is sorted in ascending order in the result. We can specify the decreasing option to true if we want to sort the vector in descending order. To sort a data frame by using one or more variables, we need to create an integer index vector by using the order function. Then we can use this index vector to sort the data frame.
For illustration purposes, Painter's ABC is created by keeping only the observations, with school variables equaling to A, B, or C.
We will use this data frame to illustrate how to sort the data. The first example shows how to sort the data by its row names. The order function creates an integer index vector, based on the order of row names. Then we place this index vector at the first position within the square bracket, which results in a data frame, sorted by its row names. The order function also has the decreasing option, which can be used to order one or more variables in descending order. This example shows how to order the school variable in descending order. This example sorts school in ascending order, and within each level of the school variable, the data is sorted by the drawing variable in ascending order. If we use the decreasing option, it will apply to all the variables being sorted. This example sorts the school and color variables in descending order. When we sort more than one numeric variable, we can use the negative sign to control which variable needs to be sorted in descending order. This example sorts school in ascending order, color in descending order, and drawing in ascending order. To use the negative sign to sort a character variable, we need to use the xtfrm function first. This function creates a numeric vector, which has the same order as its argument. This example sorts the school variable in descending order, and drawing in ascending order. By default, the order function places the missing values at the end. We can set an a.lastArgument to false if we want to place the missing values at the beginning of the result. We can also remove all the missing values in the sorted result by specifying an a. Now, let's talk about how to work with duplicated data. The unique function can create a vector with unique elements. The first example shows how to keep the unique element of a given vector. If you specify the from last argument to true, the last, or the rightmost identical elements will be kept in the result. The duplicated function generates a logical vector, indicating which elements of a vector are duplicates. The second example shows negating the result from the duplicated function, and placing it within the square brackets, is equivalent to using the unique function. The duplicated function also has the from last argument. Both unique and duplicated functions can be used for a matrix. The unique function creates a matrix, with unique rows or columns. The duplicated function generates a logical vector, indicating which rows or columns are duplicates. We will use the map matrix, that contains both duplicated rows and columns, to illustrate some examples. In map matrix, the duplicated rows are highlighted in the red boxes. By default, the unique function removes duplicated rows. The duplicated function indicates which rows are duplicated. We can also specify from last argument to true, in the unique function, when we work with a matrix. If we want to remove duplicated columns, we need to specify the margin argument to 2, in the unique function. This margin argument is also available for the duplicated function. When working with data frames, the margin argument cannot be used, because we can only use the unique, or duplicated function, to either remove duplicated observations, or indicate which observations are duplicates. We will use the dat data frame to illustrate some examples. For example, the last two observations are identical. Using the unique function, removes the last duplicated observation. In this example, we would like to create a data frame, to contain records of patients' first visit. First, we need to sort the data by patient's ID, and visiting time in ascending order. Then we use the duplicated function, to create a logical vector indicating which IDs are duplicates. Negating the result from the duplicated function, creates a logical vector indicating which observations contain the records of the patient's first visit, since the data set is previously sorted by visiting time within each patient. Placing this logical vector at the first position within the square bracket generates a data frame with patient's first visiting time. At this point, someone might raise a question. Why don't we compare the visit variable with value 1 to indicate which observations contain the information of the patient's first visiting time? It works for this data set. However, it will not work if the visit variable contains other types of values, such as using the actual date as visiting time. Similarly, we can create a data frame that contains patient's last visiting time. This time, we need to specify the from last argument to true. The idea is like the previous example. When we work with a data frame that contains multiple measurements for each person, we might need to create a data frame with only one measurement per person, and another one with multiple measurements for each person. We can use the duplicated function to find out which values in the ID variables are duplicates, and use this logical vector to extract duplicated IDs. Once we have the duplicated IDs, we can use the is.element function to check whether each element in the ID variables belongs to the duplicated ID, and use this result to create a data frame with multiple measurements for each patient. Negating the result from the is.element function generates a data frame containing patients with only one measurement. In the last section of this video, we will learn how to merge data frames, based on the common values of a variable. Data 1 is a data frame containing ID and var1, and data 2 contains ID and var2. By default, when we merge two data sets together, by using the merge function, data will be merged based on the values of the common variable names. In this example, it is the ID variable. Only the observations with the common ID values will be kept in the result. If we want to keep all the ID values from data 1, which is placed in the first argument of the merge function, in the result, we can specify all.x to true. Since ID number 2 is not in the data 2 data frame, var2 is set to missing for this observation. Similarly, if we want to keep all the ID values from data 2, we can set all.y to true. To keep all the values of the ID variables, from both datasets in the result, we can set the all argument to true. There is also a by argument, which is used to specify which variables we like to use to merge. In this example, it is not necessary to use the by argument, because ID is the only common variable between these two datasets. In this example, we like to merge data 2 and data 3 by the ID variable. Notice that the name of the ID variable in data 2 is in lowercase, and it is in uppercase in data 3. var2 is the common variable between data 2 and data 3, but we don't want to merge these two data by var2. In this situation, we can specify by.x to lowercase id, and by.y to uppercase id. The var2 variables from both datasets are kept in the result. The suffixes .x and .y are placed after var2, to indicate which variable is from which data frame. If we want to better control what suffixes to use, we can add our own suffixes, by using the suffixes argument. Now, let's review what we've learned from this video. In this video, we learned several tools for manipulating data. We started with examples of subsetting data frames, by using different types of index vectors. We also learned how to create variables based on existing variables. Then we learned different ways of sorting a data frame, by using the order function. To work with data with duplicated records, we learned two useful functions, such as unique and duplicated. Lastly, we learned how to merge data frames, based on the common values of a variable. I hope you enjoyed this video. Please like and subscribe to my channel, and click the bell icon to get new video updates.